this video we'll have a look at polynomials and operations of addition, subtraction and multiplication. So first up, a polynomial is an expression with many terms separated by plus and minus signs usually, and with different powers. So my first example here is a linear function, and it has a degree of 1 because that is the greatest power on our variable of x. Our next function is a quadratic. It's a degree 2 function. We can see that the x term has a power of 2 as a maximum. Next, x power 3, degree 3 is a cubic, and x power 4, degree 4 is a quartic. And notice the coefficients, so a, b, c, etc. are all real numbers, no imaginary terms involved here. So first up, the addition and subtraction of polynomials is quite simple. All we do is collect like terms. So for part A, if I were to add these two polynomials, p of x and q of x together, then I would combine the x cubed terms together first, and I would get 3 lots of x cubed. Then I would work with the x squared, so I've got minus 2 plus 1, so minus x squared. My x term, I've only got the one x term, and my constant terms, I've got a minus 5, minus 1, so minus 6. So straightforward, just collecting like terms. Likewise for part B, if you worked out the difference of these two, collect like terms again, so x cubed minus 2x cubed, we get negative x cubed. Then my x squareds, I've got minus 2 minus 1, so it becomes minus 3x squared. I've got plus 3x, and that's all I have for x. Then minus 5 minus 1 becomes minus 4. So very simple. Next we look at multiplication, and the first example is scalar multiplication, where a scalar is a constant. So here I have that 3 is the scalar, so 3 times by p of x. So for part A, all we do is multiply each term in the p polynomial by 3. So I end up with 3x power 4, 6x cubed, 12x plus 21. And for part B, you do much the same, multiply every part of the polynomial by negative 2. And we end up with this expression. Next we'll look at polynomial multiplication, where we multiply two polynomials together, and there's a few ways we can do that. The first technique we shall use is using the distributive rule. That means each term in the first polynomial multiplies each term in the second polynomial. So in my first example here, this x power 3 term will multiply everything in q of x, and then negative 7x multiplies everything, and finally the 4 multiplies everything in that second polynomial. So in this case, p of x times by q of x, so we have our x cubed timesing that polynomial, you would get 2x power 5, 3x power 4, and 5x cubed. Next we have our negative 7x multiplying our polynomial, so let's do that. And we end up with those 3 terms. And finally, the plus 4 multiplies q of x to give us those 3 terms. So now, collect all the like terms, and here is our final result. A second way of performing this multiplication is to use long multiplication. So in this case, we'll set it up with one polynomial above the other, but when we write these polynomials above each other, we must make sure the place value appears. So for p of x, we can see there's no x squared term, so we have to write down x cubed, and then we have 0x squared minus 2x plus 4. Underneath that, we make sure that the place values are all lined up vertically. So the 2x squared is under the 0x squared, the 3x under the minus 2x, and the constants are lined up. So now we can multiply. So now the 5 down here multiplies the top row. You put a 0 down for the second row, multiply the 3x to the top row, and now you'll notice that our x terms line up. If I do 3x times minus 2x, I get minus 6x squared, so the x squareds line up. 3x times by 0x squared is 0x cubed, and then 3x times by x cubed is 3x power 4. Now for the final row, we place 2 zeros and multiply the 2x squared to that top polynomial, and we get that result there. So now we need to add our columns. There is no carryover in this multiplication, so we add our constant terms to get 20. The x terms add to give 2x. I have 2x power 5. So this polynomial is the product of p of x and q of x. Now the next technique is still long multiplication, but rather than writing down all the x terms, what we can do is just look at the coefficients. But then it's very important that we make sure that the place value isn't forgotten. So when I write p of x, I'll just write the 1, then a 0 for the x squared term, minus 2 and 4, and underneath make sure everything lines up, so the 5 is the constant, 3 for the x term, 2 for the x squared. Now if we multiply, do the same as before, so the 5 will multiply the top row. We put a 0 down here. Now the 3 multiplies the top row, and we get that result there. Next we put 2 zeros down, multiply the 2 now with the top row. So now we add all those terms together. Once again, there's no carrying over into one column from the other. So combine those. So here's our constant. That's our x term, x squared, x cubed, x power 4, x power 5. We would now put the x's in, and we end up with our polynomial solution. Now the final technique I'll show you, and what we actually do is we use a mental calculation. So we look at the two polynomials and work out what's the highest degree we're going to end up with here. So we've got x power 3, x power 2, so our greatest degree will be x power 5. So how can I get x power 5? Well, this is the only way. Multiply those two terms together, and I will get 2x power 5. Next, we consider how can we get an x power 4. Right, the only way to do that is to multiply the x power 3 by the x term. So we end up with plus 3x power 4. Next, how can we get an x power 3? Well, we can do x power 3 times by 5, and that gives me 5x cubed. And I can do minus 2x times by 2x squared to give minus 4x power 3. Next, we look at x squared. So in the first expression here, if I were to have 2x times by 3x, that'll give me an x squared term. In fact, it's minus 6x squared. Now how else? Well, if I had the 4 times by the 2x squared, that would give me a plus 8x squared. Next is the x term. So I could times the 2x, or negative 2x, by the constant to get minus 10x. I can do the constant of 4 times by the 3x to give a plus 12x. And finally, The only way to get a constant term is to multiply one constant by another. So there's my plus 20. And if we then collect like terms, we end up with our solution, which should be the same as the previous solution. If we go back a page, we have our 231, 22, 20, and we have our 231, 22, 20 again. So the same result using this mental calculation.